I want to speak today about Redux. It's a newer, I guess people call it a state container, but it's actually in many ways a framework, though it's a framework in a very different sense from Angular or React. And we have been, it came out around the summertime. I think the first announcement was May. And we've been really excited about and adopting it on a lot of our projects here at Rangle.io. So I want to talk about how it works and what are the problems that it solves and why it makes sense, because there's some ideas in it that are a little unintuitive first, but they really actually work. So let's think about a typical complex single-page application, right? What do you have in it? Well, you have usually lots of parts, right? Because usually it starts simple, but it gets more complicated, and you add pieces because someone wants a button for this, and someone else wants something else, and usually you sort of end up with a situation where everything is connected to everything. And because there's just all of those requirements that you just end up finding, right? You start off with a lot of projects where you're going to think like, oh, it's going to be all neat where this thing talks to this thing, but it just kind of never really lasts. And the end result of this is that changing anything breaks something somewhere, right? And this is what makes maintaining a complex application really painful, right? So as of now, as far as I can see, there are two main solutions that are available that really help you manage this. One of them is component-based UI. I'm not going to talk today about this, but this is just this is like half of your solution, right? So whether you are React provides a way of doing this, so basically the idea is that you want your UI organized into components, and your components you want to stick with a fairly disciplined way and very restricted way of communication between the components, right? So you don't want to have a situation where any component talks to anyone, which is sort of the way we had the opportunity to do that with Angular 1, but React does away with that, and Angular 2 does away with that also. So this is, now obviously you can do proper component-based architecture with Angular 1, but a lot of people weren't doing that. So this is one part. I'm not going to talk about that. The second part is what I would call a stateless approach deeper in your stack. So basically, as far as the UI part is concerned, using proper use of components helps you clean that up. But that only solves the UI part. Really, chances are most of your code is really dealing with data. And the proper React components really don't help you with that at all. I mean, React, in fact, is fairly agnostic about what is it that you're going to do further down in your stack. And when I say further down in your stack, I'm not talking about your server. I'm talking about just simply the deeper levels of your front-end application. So let's talk about stateless architecture. Before I get too far into it, let me talk a little bit about why this actually is a good idea, because this may be unintuitive to some people. So a lot of us, this may not apply to all people here, but a lot of people of my generation, we grew up on object-oriented programming and this idea that you model things in terms of objects, right? And now, today, this is not necessarily taught quite maybe as aggressively, but when I was learning computer science, this was like the recent revelation received, and everyone is like, wow, we want to do object-oriented. That was the hot thing, right? Now, the key thing about objects is that objects are stateful, right? And this is something that maybe today we don't reflect on that as much, because people who actually, sort of work in computer science departments by now have sort of figured out that maybe it's not such a good idea. So objects are stateful. Now, what this means is that the effect of calling a method depends on both the arguments and the internal state of the object, right? Now, the consequence of that is every time you call a method, you might get different result, right? Because the arguments that you provide, they don't determine your output. It also depends on what has happened before. Now, this has a big downside, or actually a number. First, it's really painful to test, right? Now, the reason it's painful to test is because when you're testing an object, you created an instance of an object, and you're calling a method, what result is supposed to happen? What you don't know, because that depends on what happened before, right? So your state, in order to sort of properly understand that your object behaves properly, you need to actually test you need to call a bunch of methods start with clean slate, call a bunch of methods, and you kind of need to consider the possibility well, what if your object properly responds to this method when you call it first 17 times, but when you call the same method the 18th time, then it actually doesn't do what you thought it would do, right? So this is kind of part of object-oriented method. Now, the second part is that it also makes it actually a lot harder to understand. And now, at this point, you might even wonder, why did we even think it was a good idea? I mean, well, the hope when object-oriented programming came out was that it would somehow mimic the real world, right? Like we would have those examples like, oh, student is an instance of person, right? And it seems kind of intuitively like it's like in the real world, right? Well, I mean, the problem though is that it's not like the real world. I mean, the student in the student record in your data structure is not the same thing as a real student. And while a real student cannot actually have a reference to the actual person representation, you actually have those alternative solutions that, like in terms of delegation, in terms of other things, in data structures. So basically, you're replicating at this point in this unnecessary complexity in order to create this very superficial resemblance to the quote-unquote real world. Now, if we agree that this is what actually makes a lot of software painful today, what are our alternatives? And the main key alternative is the idea of a pure function. So a pure function is a function that the output of which depends just on inputs. So a pure function doesn't do anything. First of all, it doesn't actually have any side effects. A pure function does not do anything. It just, you give it some values and it gives you say, some values back, right? So, and then the second requirement of the pure function is that the output that it gives you needs to be determined just by the values that you gave it, right? So in other ways, the pure functions have no state, right? There's no history. If you call, it doesn't matter how many times you've called it. It just depends on what arguments you are supplying. Why is that good? Well, it's much, much easier to understand, and it's much easier to test, right? The reason it's easier to test is because what that function does is very well defined, right? If you're saying that this is a function that takes an array and returns a sum, what the correct behavior of that would be is very easy to understand, right? If you have, in contrast, a method that accepts values and then later returns a sum, then it's a more complicated discussion. Now, the second is that it's also much easier to test because, again, the correct behavior is really well defined. And when you want to test it, you get the function, you provide some values, you check the output. And you can actually build up more complex calculations starting with simple ones through composition, right? So generally speaking, if you can actually turn your code to a point where most of your code is written as pure functions, your life becomes much, much easier. Now, let's switch gears a little bit and talk about how does practice. Oh, yes, and this approach is widely used on the server side today, right? So where usually everyone knows that, I mean, if you're writing server software, your life becomes simpler if your request, your HTTP request, doesn't depend on what kind of request your server has received before. So now let's switch gears a little bit and talk about how in an SPA, how does state really become, in practice, painful? Well, let's imagine you have a component and you have a model, right? So this is like the beginning of our simple, like classic MVC, right, model. So we have a component, we have a model, and the component, sends some information to change the model sends some update, the component reflects it, and then we have, and this is all easy until we get the second component, and the third component, and the fourth component, and then we have a bunch of models, and then this component, this model affects this component, and then it also affects this other component, and then this component wants to change this model, and it starts getting basically very painful soon, right? And then this is the mess that you end up with, right? I mean, like, raise your hand if you've been there. So the solution that, a common solution that emerged recently to this goes under the name unidirectional data flow, and the particular common realization of it is called Flux. So I'm not going to get into too much details about Flux, but because Redux that I'll talk about is kind of, you could think of it as an offshoot, as a splinter cell of Flux. But let me give you a very quick overview of how Flux tries to solve this problem. So in Flux, you basically introduce a restriction. So in order to avoid this mess, right, where you have stateful components and stateful models, and where components change models and models change components, and you never really become sure which state is synchronized and which is not, you go with a much more restricted model, where you say all of the communication between components and model is going to go in this unidirectional circle. So in particular, your components, the only thing that they will do to communicate with the model is emit actions. And an action is really just a bit of data that, like, you know, it's a token with usually with a payload, right? So it's like, say, okay, we'll add this information, like, you know, register, you know, add this thing to a shopping cart, right? And then we specify the product ID and the cart ID or something like that. Then all of those actions get collected by a dispatcher, which then distributes them to stores. And store is an element that is basically holds this value and distributes it then to components. So components send actions to the dispatcher, and then they subscribe to streams that come out of the store. So it would look roughly like this. Now, in practice, it usually ends up being slightly more complicated because of asynchronous actions, right? So if your actions are a little bit more complicated than that, where they actually would require, for instance, server interaction, then you have to switch to a slightly more complicated model where your component invoke what's called an action creator. And an action creator is, so instead of just your component creating a token and a data and, you know, throwing this to the dispatcher, your component calls a function which will do that. In the simplest case, all of the action creator will do is create an action and send it to the dispatcher, and then we'll sort of see the rest of this loop. Now, in a more complicated case, for instance, if you want to actually have some server interaction, what your action creator will do is it will make a request to the API and possibly say on resolution of a promise that comes that's associated with that request, will issue then an action. Now, in practice, you will probably usually in this setup issue several actions. So your action creator, let's say that you want to save some data. So you will go ahead and you will issue or let's say you want to make a request from the server, right? So what would happen is that your action creator will start the process off by issuing an action that signifies that some data has been requested. It will then make an HTTP request, and then upon the success of that request, it will issue a new action saying that the data arrived, and then if the request fails, it will issue a different action saying that data failed, right? And then the API part, obviously that part usually you'd want to have a high-level sort of API library that abstracts a lot of the ugly details and promises and whatnot, and you now have this neat separation between your API logic and your components, right? So the nice thing about this model is that you're following a somewhat constrained approach, but at the same time, you can start adding components, removing them, and it's actually really easy, right? Because when you add a new component, your component basically just has those set of, they cannot go ahead and modify anyone else's state. All they can do is issue actions. Now, the question is, can we actually do better than that? And the answer is yes, with Redux. So let me talk about what is Redux. So you can, so here's the URL for the project. And if you Google for Redux, you'll find it too, but let me just provide it just in case. And the key component, the key concept of Redux is it's similar to Flux, but it uses a single store, and it uses something that's called state reducers. So a single store is fairly straightforward idea, right? So instead of like in a classic Flux, you actually have different sort of modules that store data for different things, right? In Redux, you just do away with that and you have a single store, which may seem unintuitive and you may think that's weird, but I'll talk a little bit about why that's actually not so bad. But the less intuitive idea is that of a reducer. So now so let's talk about it. How can single store be actually a good idea? And then what the heck is a reducer? So I'll start with that. So the reduce function is one of those things that I think it's like the least loved of the three like classic functional programming concepts, right? So there is map. I think everyone, if you've done any amount of functional programming, you've used map. Filter is a really common one. So in the map, you basically have an array, and you provide a function so that every item in this array is going to get run through this function. You're going to generate a new array. In filter, you will run all of your items through a function, and then depending on whether it returns true or false, you will either pick them or throw them away. And reduce is like the one that never gets enough love. So let me just review it very quickly, because that's a key concept in Redux. So the idea of a reduce of array.reduce, right? It's a built-in thing in JavaScript, is that you provide a function which will be executed. So it's sort of similar to map, except for it has this extra parameter where it will take there's a state. So the state is, the initial state is the second argument to reduce, so in this case 0. And what we're going to do is we're going to add a function, we're going to define a function which will take a value. So a value is going to be one of those items, and the state, and what it does is that it adds them up, right? Now the effect of running array.reduce with this function and 0 is the initial state is that we end up adding up all the numbers. So the way this works is we first go through, so our iteration is that first we look at 1, and our state is 0, so the output of add 1 value is 1. So for the next iteration, we are taking the second element, which is 2, and we take the current state, which is 1, and we add them up and we get 3. For the third iteration, we get the third item, which is 3, and the current state that is 3, and get 6. Then we get the fourth item, which is 4, and the current state that is 6. And then this way, we basically just go over it and over the whole array, and we add them up. Right? So that's the kind of key idea of reduction. So Redux takes the same, and as you can see, the Redux, the reduction is right there in the name of it. It takes that idea and turns it into idea of action reducers. So the idea, an action reducer is a function that takes it's a function that takes an action and the state of the application and gives you a new state. And your application state in this setup ends up being just a reduction over all of the actions, right? So you can think of from the moment your application loads, there is a history of actions, right? So every time something happens, there is an action, right? And you have action reducers, which are basically functions that take your actions and generate the next state given that action. So if you take your application and you go through all of the actions, then you get your current state, right? Now, the interesting thing about this is that it makes your application state replayable, right? Like you can always go back and say, let's pretend that this didn't happen. Or you could say, let's start from the beginning and replay all of this. So in that sense, your application sort of has a state, but it sort of also doesn't in the sense that your state is actually always derived. It can be derived on the fly. If you forget where you are, all you actually need to do is start with your initial state and rerun all the actions by running the action reducers on each of the actions. Now, each reducer in this setup operates on a subset of global state, right? So you have your global state, you can think of it as a giant tree of data, and your reducer would be a function that will basically say, I'm going to be looking at a particular section of it, and every time there is an action, for every action, I will give you the new version of this. And then finally, what you do is so you build those really simple reducers, and then you combine them into more complicated ones. So let me give you an example of how this looks in practice. If you are into ES6, then this is how you would do it in ES6. I'll give an ES5 example in a second. So we are creating so this is a note-taking application, and it has a reducer that deals with nodes. Now, there are other parts of that application, but there's a particular branch within the application state that deals with information about the nodes that we've entered so far. And we are going to have for now just two actions, and one of them is going to be update node content, right? So every time we want to save new content into a node, some component is going to trigger the update node content event. And then, or rather, sorry, to be more precise, a component will call the update node content action creator, which will actually probably make an HTTP request, and upon the end of the HTTP request, when we've got confirmation that this is updated, we'll then issue the actual update node content action. And so what we associate here with update node content is a function that takes state and action and returns a new state. If this is easier to see in the classical ES5 formulation, right? So it is that it's a function that takes state and action as two arguments, and it returns a new state. Now, I will for now not talk about how are we actually generating new state, but the idea is that you got your state and an action, and you generate a new state. This function is meant to be a pure function, right? It does not actually, so the state.setIn does not actually modify anything. It just gives you a new value, right? So Redux is responsible for keeping track of which state are you currently at, and the important thing is that it can always recalculate it. Now, why is this a good idea? Well, the one exciting thing is that reducers in the setup are pure functions, right? And because they're pure functions, they're really easy to understand, and they're also really easy to test, right? So this code, right, the reducer code can often be a little complicated because basically you've got some data, maybe some complicated action happened, maybe some data arrived from the server. You've got your state. You're going to need to do some logic in terms of merging this data into updating your state based on this newly arrived information. So this can be potentially a little complicated, but it's also really easy to test because you can always just say, okay, well, given this state and this action, here is the new state that I expect. Did I get that state? The second thing, and this is actually kind of amazing, the reducers are actually synchronous, right? And this is a little unintuitive because, I mean, if you've been in JavaScript community over the last few years, then what we've all sort of been talking about, what all of us have had to learn is that you cannot get very far in JavaScript without thinking all the time about asynchronicity, about thinking that you can't just code JavaScript as if things happen synchronously. Well, guess what? With Redux, suddenly you can, right? Because in this setup, we are saying that, at least as far as the reducer code is concerned, and reducer code is what's going to be most of your code, you're basically saying that given this state and given this action, here is the new state, right? It absolutely doesn't matter when that happened in time. It doesn't matter what happened before. It doesn't happen, it's not in the time, in the future, it's not in the past. It's more that it is just kind of like mathematical, right? It just, when this is true and the other thing is true, then the third thing becomes the output. So a lot of your code becomes synchronous, and this is kind of amazing in JavaScript. The third is your data logic is now 100% separated from view logic, and that is very, very nice. And the cool thing is that you can actually still have modularity by combining simpler reducers, right? So in this case, let's say in the application that I was showing, you can have we could have a reducer for nodes, which keeps track of information about nodes. We could have another reducer that keeps track of information about the user. We can have a few other ones, and then they are merged into this overall state, and then we can define effectively projections into that state where we can say, well, we want to take, for our components, we could take a slice of that state and show that to a component. Now, an important thing again, though, is that this state is completely unmodifiable, right? So within this model, your components cannot ever do anything to actually modify state. All they do is, the only way they affect this is that they issue actions, actions run through reducers, reducer calculates new state. No, the third and the last item that makes this really exciting is that this gives you new opportunities for tools, like of the kind that is actually kind of even hard to, I guess imagine, it was up until recently hard to imagine in JavaScript. So let me give you a little example of what you can end up getting tools-wise. So this is that's not very exciting. Oh, I guess I see what happened. So this is the node-taking application I was talking about, and this black chunk there is a Redux developer tools panel. What? Make it bigger. Oh, I see. Big enough? Okay. So what it does is it actually shows you a history of all actions, and for every action, it shows you the previous state, it shows you the action that arrived, and then the new state that got calculated based on that. So what I'm gonna do is I'm going to here, and so we can see all of them here. So as we can see, the first thing that happened is that we actually got, we made the request for fetching nodes, and when the new nodes arrived from the server, then a bunch of stuff got displayed. And what I'm gonna do next, something really weird happened to my CSS there. I'm gonna create a new node, and then I'm gonna change the content of it to hello TorontoJS. And I'm gonna save it. And what we can see here, right, is that here's the things that happened, right? So there was a fetch nodes action, and then the add node happened, and then so we could see what happened with, so the add node basically, well, there's no information in the action. We just ask for a new node to be created. Then we can see the new state. So here we had nodes had 3 entries, and here we now have 4 entries. No, we still have 3 entries. I'm not sure why. Weird. Oh no, sorry, because it's yeah, because I'm not looking. It's those 3 entries. So I'll see here I have 9 nodes, and then here I should have now 10. So debugging becomes a lot easier, right? And then what we see here is that we've actually got update node content arrived with partial part of the string because it saves it continuously. As I type, it saves it. And then we've got a second instance of that event that basically said, that spelled out the whole thing. And now here's something cool that I can do is I could say, I can just cancel them. I could basically tell my application, let's pretend that action didn't happen. And if it didn't happen, well, I guess now we are back to where we were, right? Like the content here changed, right? So, and then I could in fact go and, oh, sorry, I'm sure I had this scrolled to the wrong one. Oh, that's annoying. So here I'm in a partial state, right? And here let me cancel this one. So now it's back to how it started, and I can then go and change the just get rid of the action of the new node creation. And what's even cooler is I can actually cancel them in different, like I don't need to cancel all of them sequentially. I could say, let's pretend that we did actually send an update, but we did not create the node, right? So what state are we going to be in? Well, I mean, so in this case, what we see is that the way this application works now is that if the creation of new node didn't fire, but then we sent an update, then the new node didn't get created, right? When we go into our nodes, we should still see 9. And I guess the update action in this situation has no effect, right? So it gives you suddenly debugging opportunities that, you know, are really quite amazing, right? And what you can do further is, I mean, you can do all sorts of things. You can commit it. You can say, let me save it in this state. And in fact, the coolest thing is that you can take, you can basically take your session and share it, right? So you can basically, when you got to a particularly nasty state in your application, you could take that, serialize the sequence of actions, send it, and send it to someone else who can actually then jump straight into that. So those are some of the things that you get. So let me, I'm not going to test the gods of demos more, since that always never ends well. But let's talk now about, so there's a few though edge cases. There's a few things that are making things a little bit more complicated that we need to look into. One of them is avoiding mutating state. Now, Redux requires you to write pure functions, right? So those pure functions, they're supposed to take the old state and the action and give you the new state, and the new state needs to be a new state. Like it needs to, like it assumes that you are honest, and you're not going to go ahead and either try to modify the new state or take the old state. So take the old state and send some kind of modified version of it, like in the sense that like if someone, when Redux calls you with a pointer to the old state, it expects that state to not change, right? It expects that when you, like a lot of this traveling back in time assumes that if it sends, that what it gave you a reducer is gonna stay untouched, right? Now, this is a little bit difficult to achieve in practice, right? Because I mean, your reducers are supposed to not change the old state, but how do we actually keep them honest? Because if we don't keep them honest, if we actually make a mistake of modifying old state even inadvertently, then a lot of this stuff doesn't actually work anymore. So the idea is, I mean, the immutable state, so you want some form of immutable data structures. I mean, basically some way of storing state without, or storing data without introducing state in the sense of introducing something that's mutatable, something that you can actually go and change even inadvertently. Now, the most sort of naive way of doing this is with object.freeze, but this gives you actually a very shallow freezing, right? So you really don't have a guarantee that things aren't going to get modified further down in your tree. There are certain cases where you would want to, if you're looking for something like object.freeze, but actually that freezes your data structure all the way down, then you're probably looking for a library called seamless immutable. So this basically gives you something that looks just like JavaScript objects and JavaScript arrays, and but it basically will make sure that it's frozen all the way down. Now, in practice, though, and this is maybe an odd question to ask when talking about immutable data structures, is, well, what do you do when you actually want to modify your data? Because you do need to actually generate the new state, right? So, I mean, this is maybe a somewhat sort of odd question because, well, the immutable objects, by definition, they don't change, but you also need to change them because you need to derive this new state, right? So what you want is you want this derivation process that does not affect the object that you started with, and ideally would actually be happening effectively, right? Because you could be cloning your state, but cloning your state potentially can get very inefficient. So you need this new way of generating new state without altering the original, and Immutable.js is the library to use this, right? So I would say, practically speaking, when you're using Redux, you probably want to be using Immutable.js, and if you are gonna, if you go to Redux documentation, they seem to want to kind of try to make it seem like you could do it without Immutable.js, but maybe not to scare you, but no, you can't. Like, you want to learn Immutable.js. Immutable.js is an amazing library, and if you're using Redux, you should just bite the bullet and actually learn Immutable.js. So the way this works is basically the following: is you have an Immutable.js data object, and then if you call, for instance, a method, there's a bunch of methods there. It behaves differently from a JavaScript arrays or objects, but so for instance, if you want to actually set a value, instead of doing data.foo.bar.buzz equals 42, you will do data.setIn, and then you provide the path under which you want to change it, and then you provide the value. But the cool thing about this is that it gives you something else, something that you don't actually usually get with normal data structures, which is that after you run this code, you can use your new data as representing this new state, but at the same time, the old data object is still pristine. It's still in the exact same state. So any method that you call on data, initial data object is going to be exactly the same, give you exactly the same result. So Immutable.js is really, that's the key building block for stateless architecture and for Redux in particular. Now, the second challenge is handling asynchronous actions. Now, I gave you the preview of this. Is basically you want to have action creators that would probably usually dispatch an action announcing that something is going to happen, and then make a request with a promise, and then dispatch another action on success. So the action creator emits an action, informs everyone that request is made, then it emits another action to inform everyone that request was completed or when it failed. And you want to push, of course, the details of making a request into a module. And so here's roughly an example of how it would look like. Okay, so this is just this is the in-action create. This is the very basic action creator that actually creates an action, and in this case, it takes a status. So this is like, we made the request, we got results, and some data, and then the way we would use it would be like this, right? So we're basically saying that when someone makes a request to fetch nodes, we will immediately dispatch a fetch node action with status being request, and then when the data arrives, we will dispatch create a variation of this action that has the JSON as the payload and the status success, and if it fails, we'll dispatch a variation of this node that has error as the payload and status as error. And then finally, testing actually is really easy. So because in this case, so if we want to test, for instance, that adding our add node action has the proper effect on reducer, the way we would do this is we'll say, okay, let's take our initial state, let's calculate, let's say in this case, the length. Let's run the add node action through this reducer and get a new state. And then we can make a bunch of assertions about the new state. It's really that easy. And the amazing thing about most of your code, you will be actually now testing in a synchronous way, right? A lot of your asynchronous code is actually gone. In terms of integration, so this works with React Angular 1 and Angular 2. For React, you will be mapping state, parts of state to properties, and you will be mapping React handlers to functions that dispatch actions. For Angular, you will be mapping state and dispatch, both mapping them to this. The Angular method ends up being a little bit more awkward, but it actually still works fairly well. It's still the best way to use Angular, in my humble opinion. And then finally, caveats. Nothing is perfect, so neither is Redux. The one big downside is that it's very addictive. When you start using it, then you just can't stop. The second one is that you probably will no longer be happy using anything else, and that can be a big downside, and in fact, even kind of an employment hazard, because you may end up finding coming to work and then discovering that you cannot convince your company to start using Redux, but you really don't want to use anything else. So in which case, you give Rup a call over there, and then you come work for us. And then your friends just might end up not being able to understand your obsession with it. And again, if you find yourself lonely, come to us. So thank you very much.